This movie is presented by Systemverilog Academy, and please do subscribe our channel for more Systemverilog design verification and UVM videos. Also visit our website at systemverilogacademy.com to find more Systemverilog courses and training programs. Hello, welcome to this course, UVM in Systemverilog, Quick Start for Absolute Beginners. My name is Ajit Jose. I'm a VLSI design and verification engineer with more than 10 years of industrial experience. This is a basic level UVM course. So in this course, you will be getting introduced to the UVM methodology. And this is primarily targeting verification engineers who wanted to start in UVM, who have no prior experience in UVM based methodology. To make this course effective for you, you need to have the basic knowledge of Systemverilog based test bench, and also it is good to have some idea about object-oriented programming, because UVM is all about classes in Systemverilog. And inside the course, first you will be getting introduced to the UVM methodology, then you will see a generic UVM based code for all the UVM classes, and finally you will go through a complete example of developing a UVM based test bench. In that exercise, first you will see how a simple Systemverilog test bench with no classes are written with a dummy DUT as well. And next you will see how this same TB is converted into a class based test bench, and finally you will see how it is converted into a UVM based test bench. In this process, we will completely explain all the classes in UVM one by one with examples, so that you will be able to understand how you can start writing your own UVM based test bench. Thank you very much for your interest in this course. I hope this course will be relevant for you and you will learn a lot from this. And please leave your honest review about this course while you go through this course, and happy learning. Introduction to UVM. In this session, you will be getting introduced to UVM. So the first question is, what is UVM? UVM stands for Universal Verification Methodology. It is a standard set of classes which is written in Systemverilog language. These classes are written by experts from the industry. It is not written by a single person or by a single company. It is a combined effort of a lot of people, which is supported by all the major EDA companies. And as it is a set of classes, UVM can only be used for verification. So you can never use any of the UVM components in your RTL design phase. Now UVM is also an IEEE standard like Systemverilog, and as I said earlier, it is supported by all the three major EDA vendors in the VLSI industry, and it is widely accepted in the industry as well. Now the next question is, why should you choose UVM in your test bench? So the answer is to ease your work of developing a standard test bench, and also to reuse verification components in both vertical and horizontal domains. So as I said earlier, UVM is a set of classes which is written by professional people, and it is well-defined, experimented, proven methodology. If you have already a verification test bench which is written in Systemverilog or in some other language, and if you are trying to adopt it, of course there is an initial pain and investment of doing the bring up, but once you have written the test bench or converted a test bench into UVM, it is giving you a well-defined, well-standardized methodology. From that point onwards, you'll be able to reuse all your verification components across projects and across different hierarchies. Most of the major companies and even smaller companies have already adopted UVM. Therefore, it's a must-have skill set in the verification industry. This is a brief history of the UVM. And you just understand that UVM is derived from OVM and also have adopted a lot of VMM methodologies. These are the methodologies adopted by Cadence, Metagraphics, and Synopsys. And finally, all the three major vendors, EDA vendors, have came together to develop the standardized universal verification methodology. OVM and UVM. Some of you might have already learned OVM, or very rarely you might wanted to learn not UVM but OVM. Here is a quick comparison between both. OVM, the open verification methodology, and UVM, the universal verification methodology, are very much similar in nature, especially for a beginner. But UVM has a lot of features and functionalities available than compared to OVM. So even if you're planning to learn only OVM at this phase, I would recommend you to go ahead and master UVM at the end, because that is an industry standard methodology. Basic UVM classes. As you have already seen, UVM is a class library. So in this session, you will be learning the bare minimal set of classes that is needed to start with developing a UVM test bench. There are two categories of classes in UVM, which is UVM component classes and UVM data classes. So these are the essential component classes needed in any test bench. These are driver, sequencer, monitor, agent, environment, and tests. And these are the essential data classes that is required in any test bench, which is a transaction class and a sequence class. Thus, when you are writing a UVM based test bench, all that you have to do is to write all these classes, your own classes, which is extending from all these corresponding base classes. So in simple words, you need to write a driver, your own driver class, which is extending from the UVM driver, and you need to write a environment class which is extending from the UVM environment class, and so on. Before explaining all of them in detail, let's have a quick look at the UVM class hierarchy. So this is a simplified UVM class hierarchy. The most basic class in UVM is named as UVM object. It is not 100% true. The very basic class in UVM is called UVM root. You can ignore that, and you can consider that UVM underscore object is the base class for all other classes in UVM. And remember that this is not an object, this is a class definition itself. UVM underscore object is a class definition itself. These are the data classes and these are the component classes. And also note that apart from these most generalized data classes and component classes, there are a lot of other set of classes available in UVM which is not needed to learn as a beginner. So as a beginner, this is a bare minimal set of UVM which you need to master. This is component class hierarchy. A class named UVM underscore report underscore object is derived from the UVM object, and the UVM underscore component class is derived again from the UVM report object class. So this is not commonly used, and UVM underscore component is the base class for all the UVM component classes that I have listed here, like driver, sequencer, and monitor. So the name of the UVM defined classes are like UVM underscore test, UVM underscore env, UVM underscore agent, UVM underscore sequencer, UVM underscore driver, and UVM underscore monitor. And all these classes are derived from the UVM underscore component class. When you develop your own UVM based test bench, you need to write your own UVM test which is extending from the UVM underscore test, and you need to write your own UVM environment which is extending from the UVM underscore env class, and so. And in the data side, these are the data classes. The first, from the UVM object class, a UVM underscore transaction class is derived, and from this UVM underscore transaction class, a UVM underscore sequence underscore item class is derived, and from this class the UVM underscore sequence is derived. There is one point you should note here. So these are the essential UVM data classes that you need to write in your test bench, like the transaction and sequence class. And remember that the UVM in your test bench, you will be writing your own transactions which is extending from the sequence item class, not from the transaction class. Or in other words, the UVM underscore transaction class will not be used to extend other transactions, but to write your own transaction, you will be extending those transactions from the UVM sequence item class, and your own sequences will be extending from the UVM sequence class, as in the case of other test and environment classes, etc. This is a simplified class hierarchy diagram in UVM. And what you need to learn is to write your own test, environment, agent, sequencer, driver, monitor, transaction and sequence classes which are extending from these corresponding classes. A generic UVM based test bench. This is a generalized UVM based test bench diagram. In the previous session you have learned that you need to write your own test, environment, agent and some other classes in order to write your complete UVM based test bench. And this diagram shows how will you place all of these components into a test bench. So if you see closely, this is your design under test or DUT. This is your UVM based test class. So you will be instantiating all of your UVM based components within a UVM based test class. And finally you will instantiate your UVM test class and the DUT in the top test bench module or the top module. So this, even though this is written as a UVM test bench, this is a general Systemverilog module which is instantiating both this DUT and the final UVM test class. Now we'll see what are the components in the test class. Within your own UVM based test class, you will have your own UVM based environment class. So remember that this UVM test is your own UVM test which is extending from the UVM underscore test class, and this UVM environment will be your own env which is extending from the UVM underscore env class, and so on. And the test class will contain the env class, and within the environment there will be multiple agents. There could be one or more agents, and this is the UVM based agent class. And also it is not shown here. In a UVM agent there will be three kind of categories of classes, which is the driver class, the monitor class and the sequencer class. So the sequencer, driver and monitor all together will be instantiated within an agent class, and multiple agents could be instantiated within an environment class, and multiple environment classes could be instantiated within a test class. And there will be only final single test class which is running at in a particular simulation, and thus that is a final UVM based test class which is instantiating in the top level module along with the DUT. If you have noticed here, the sequence classes will be running from the test class. You can ignore the configuration or factory classes for the time being, but note that the sequences will also be starting from the test class. And the sequence class will again consist of multiple transactions classes, and there could be multiple sequences running from the same test class. Another thing that I wanted you to notice here is that the DUT is directly interacting only with an agent in a UVM based test bench. To be more specific, the DUT will be interacting only with a driver and monitor class within an agent in a UVM based test bench. None of the other classes like the test, environment, even the agent class, the sequence, any transactions, or even the sequencer will not have any direct interactions with the design under test or the DUT. Only the driver class and the monitor class which are sitting within the agent class will be interacting with the DUT in a UVM based test bench. Here is a quick summary of a generic UVM based test bench. Your test class will encapsulate all other your own derived UVM based classes, which are like the environment and sequence classes, and the environment will be consisting of one or more UVM agents, which again are consist of driver, sequencer and monitor classes. And along with your DUT or design under test module, you will be instantiating your UVM based test class within the top level module, which is a Systemverilog specific module. Writing UVM classes in Generic. In the previous session, you have learned that there are two categories of classes in general in UVM, which are UVM component classes and UVM data classes. And now onwards, you need to write your own classes which are deriving from the standard UVM classes to make your own UVM based environment. To help that process, in this session you will be learning a generalized code for each of these category of classes. That is, you will be learning how a generic UVM component class will look like, and also you will learn how these UVM data classes will look like. First, you will learn component classes. This is a generalized form of any UVM component classes, and this is applicable for all of these classes, either a UVM test or an environment ENV, an agent, sequencer, driver or monitor. We will learn all of them in general, and when you go through the examples, it will be helpful for you to understand if you know the general structure of all of these classes. So first is your own class name. Say here it is my component, which is extending from the corresponding UVM component. So if you are writing your test, then you will be extending from the UVM test. If you are writing your ENV, you will be extending from the UVM ENV and so on. Also, it is possible to extend from the UVM component itself, but as a beginner you don't need to use classes which are extending directly from the UVM component. Immediately after the class name definition, the first line in any of the UVM component classes should be a factory registration macro. So this is the factory registration macro, which is common for all of these classes. So whether you are using a UVM test or UVM agent or UVM driver, for all of them you will be using the same macro with name UVM underscore component underscore utils. Since it is a macro, you need to use this symbol which is specific to the system syntax. And also within the bracket you need to pass the same name which you had given for this class in the beginning. So if it is my component here, it should be again my component here. Now at this point you might be wondering, what is a factory registration? So this is a special mechanism provided with the UVM library, and it's a powerful technique to reuse your UVM components, your own derived UVM components, without changing the actual code in several places. At this point you don't need to bother what is UVM factory and how it is utilized, but you just understand that with every UVM derived classes you have to give a factory registration macro immediately after the first line of this class definition. And for all of these component classes, the factory registration macro name is UVM underscore component underscore utils. Also note that since it is a Systemverilog macro, you will not be writing a semicolon after this macro definition. Next, you will define all the internal members of the class, which is same as that of in any Systemverilog specific class. And first you can give all the virtual interfaces which need to be part of this class. As you have learned from the previous session, the only classes which are directly interacting with the DUT is a driver class and a monitor class. So this part, a virtual interface handle definition, will be part of only a driver class or a monitor class, and none of other classes will have a virtual interface handle within it. Next, we can list all the internal members of this class, which could include other UVM component classes as well. For example, if this is an agent class, it should contain a handle of a driver class, a monitor class, and a sequencer class. After all the internal variable declaration, next you need to write all the functions and tasks which are specific for this UVM components. These are the methods which you need to write for all of these classes. So like in any Systemverilog class, you need to specify a new function which is a constructor of the class. Next is a build phase function, and next is a connects phase function, and also you need to write a run phase task. For the time being, you can ignore what is the content of these functions and tasks, but just understand that in all these UVM component classes, you need to write all these functions. You need to write a build phase function, a connect phase function, and a task which is run phase tasks. There could be additional functions like end of elaboration, start of simulation, etc., which you can ignore at this point. And to summarize this session, this is a general outline of any of the UVM component classes listed here. So those will be extending from the corresponding component class, like a driver will be extending from a UVM driver, and a ENV will be extending from a UVM ENV, and so on. And next, immediately after the first statement, you will write the factory registration macros, and if there are any virtual interfaces, you will list them, and it comes all the member variables and other member classes of this class, followed by a new function, a build phase function, a connect phase function, and a run phase task. In the previous lecture, you have seen how to write any UVM component classes in general. Now you will learn the generic structure of UVM data classes. So as we have already explained, there are only two UVM data classes that you will use in a UVM based test bench, which are a class to represent your sequence and a class to represent your transaction. So the sequences are extended from the UVM sequence class, and the transactions are extended from the UVM sequence item class. So this is how your your transaction class looks like in general. So the class, you can give any class name for your transaction, and all of them should extend from the UVM sequence item. And next is the factory registration macro for the data classes. For the data classes, the factory registration macro is UVM object utils. If you remember from the previous session, the factory registration macro for the component classes were UVM component utils, and for the sequences and the transactions, they are UVM object utils. After the factory registration macro, you will list down all the data members of the transaction class. Typically, those will be the transaction items that is getting exercised in a particular interface. It could be the individual items of a structure, whatever it is. And after the generic data member declarations, you might write constraints specific to these data members. Constraint is a Systemverilog specific concept, and it is not new in UVM. So UVM is just using the Systemverilog constraints. So it's not necessary that you should use constraint, but typically you might want to use constraints in especially transaction classes. Also note that the data members could be declared as random variables just by adding the ran keyword in Systemverilog. If you are not familiar with the random keyword and the constraints in Systemverilog, you can quickly go through any of the Systemverilog specific manual, or just understand that just by adding the ran keyword, you are making this value of this member as a random value when you are calling a .randomize function with this object, with any of the object of this particular class. And the constraints are added to limit the randomness of these random members in such a way that which is generating valid stimulus to the DUT. After adding the constraints, you want to write the functions which are specific to the sequence item class in UVM. So these are the standard Systemverilog construct new function, and also you might want to write few of other functions like do copy, do compare, etc. In most of the cases, you have to write an implementation of a do copy and do compare class for the transactions, and these functions will get called automatically when a copy function and compare function is getting called with any object of this transaction. For the time being, you can ignore these functions, but just understand that this is a general outline of any UVM specific transaction. So this transaction will be extending from the UVM sequence item. It will have the factory registration macros followed by the member variables and the constraints, if any, and you also will see the definitions of these functions in the transactions. Next is the generic outline of any UVM sequence class. So the sequence classes will be extending from the UVM underscore sequence class. Here the class name is my sequence, and also note that this immediately after the first statement you will give the factory registration macro for the data classes which are UVM object utils. Within the bracket you will pass the name of this class as the argument to this factory registration macro. And After that, you can define or declare any data members for this class if there are any. And these are the functions and tasks which are present in the UVM sequence class. So there should be a new function, the constructor functions, like in all other classes. And also there is a task named body. So this task named body is specific to UVM sequences. You will not see any these tasks with a name body in any of other classes, either in the UVM sequence item class or in any of the UVM component class. This is a main method of this UVM sequence class. This is where you will write the intelligence of the class inside the class definition. So all your functionalities or most of the functionalities will be written within the body task of the UVM sequence. That's the end of this video, and if you like the video, please do subscribe our channel and also visit our website at systemverilogacademy.com to find more Systemverilog courses and training programs. Thank you for watching.